Hello, my name is Ardi and we are going to solve problem 4.5 from Nilsson and Riedel book. So the question is like this. A current leaving a node is defined as positive. A. Sum the currents at each essential nodes in the circuit shown in figure P4.5. So there are 3 essential nodes, right? And then B, show that any one of the equations in A can be derived from the remaining 3. I think 2 equations. That should be 2. Remaining 2 equations, right? Maybe. Because we only have 3 equations, right? So we start from A here. Sum of the currents. Okay, and we define the current leaving the node as positive. Okay, maybe let's start at node 1. At node 1. Okay, the positive one is I2 and I1. So I think we can just add them up. I1 plus I2. But then Ig is going into the node. So the sign will be negative, right? So I'll have minus Ig is equal to 0. And this is the equation for essential node number 1. Okay, let's move on to node number 2. At node number 2. At node number 2, the only current that goes in is I2, I3, and I4 is going out. So the positive one is I3 and I4. I2 is going in, so the sign will be negative. So I will have minus I2 is equal to I3, not equal, minus I2, and then plus I3 and I4. And all of that will equal to 0, right? And now the last one, we will have at node 3. At node 3. Okay, at node 3, the current that goes out is Ig, so the sign will be positive for Ig, right? So I will have Ig to be the positive one. And then I3 and I4 is negative, so I will have, I think we have to write minus I3 minus I4 first, and then plus Ig. All of that will equal to 0. Okay? Okay. The question B, show that any one of the equations in A can be derived from the remaining 2 equations. Okay? Maybe let's just sum them up. So B, maybe let's name this equation here as equation number 1, equation number 2, and equation number 3, right? So if we sum equation 1 and equation 2, if we add them, we will have, so we will have, what is it? I1, okay, we still have I1. And then I2 minus I2, that will cancel into 0, right? And then we will have minus Ig. And then we will have plus I3 and plus I4. Plus I3 and then plus I4. And that will equal to 0. Oh, I missed one more current here. So I1 is also goes in, so I'll have minus I1. So this is equation number 3. Okay, and we can rearrange this by moving all of them to the right hand side. So we will have minus I1 minus I3, and then minus I4, and then plus Ig. That will equal to 0, and that is exactly equation number 3. Okay, And we can also add equation number 2 and 3. Okay, maybe let's duplicate this slide and redo equation number 2 and 3, and let's see if we get equation number 1. Okay, let's redo this, and we have equation number 2 plus equation number 3. And equation number 2 is this one. Okay, we still have I minus I2, right? So we will have minus I2. And then we also still have minus I1. Okay, but then I3 and I4 here will cancel out with minus I3 and minus I4 there. Okay, but then we also have plus IG, and that will equal to 0. And we can flip the sign here, so I'll have I2 plus I1 minus IG is equal to 0, and that is exactly the same as equation number 1. Okay, and we can also add 1 and 3, so we'll have 1 plus 3. Okay, I1 and I2, I think I1 will cancel each other, so I1 and I1 will cancel. We still have I2, so we'll have I2, and then we will have minus I3 and minus I4. Okay, minus I3 and minus I4. Then minus IG and plus IG will cancel each other, and so we will have this as 0. And we can flip the sign. Minus I2 plus I3 plus I4 is equal to 0, which is the same as equation number 2. So we can derive equation number 3 from equation 1 and 2. We can derive equation number 1 from equation number 2 and 3. And also we can derive equation number 2 from equation 1 and 3. And that is how we solve problem 4.5. Okay, I think that's all for this problem. See you in the next video. Bye bye.